Welcome, my friends. There's no single thing that's more important to ensure your success in trigonometry than to memorize the first quadrant of the unit circle. What I'm about to do for you here is something you should do every day for maybe 1 or 2 weeks in a row until you have it memorized. Okay, so here's what you should do. You should draw a circle, and from that circle you should draw an x-axis and a y-axis. Then you should also draw 3 angles in the first quadrant. From here, you should label all of the angles with their degree and radian measurements. So first of all, we have the positive x-axis, which could be thought of as 0 degrees or 360 degrees. Those are coterminal. We have the positive y-axis, which could be thought of as 90 degrees. Put that right here. We have the negative x-axis, which could be thought of as 180 degrees. And then we have the negative y-axis, which is 270 degrees. Okay, and then we have these 3 angles here in the first quadrant. Let's label those. So that would be 30 degrees, that would be 45 degrees, and that would be 60 degrees. And then label all of those angles with their radian equivalents. So 0 degrees is 0 radians, or 2 pi radians. Those are coterminal. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 180 degrees is just pi, and 270 degrees is 3 pi over 2. And then at this stage, we want to find the x and y coordinates at each of these angles. And don't forget that the x and y coordinates relate to cosine and sine. So the x coordinate is going to be cosine of theta, and sine is going to be, and the y coordinate is going to be sine of theta, all measured with respect to the positive x-axis. Okay, and I'm going to kind of try to do this color-coded. So let's get my colors out. Let's do all the points for cosine first. So cosine is the x-coordinate on the unit circle. So if it's a unit circle, that means we're moving out from the center to a radius of 1 to some point on the circle. So if we're going straight in the right direction, then we would have moved 1 unit to the right. So the point is going to be 1 for cosine. If we move straight up, we're at the angle of pi over 2 or 90 degrees, then we haven't moved in terms of the x-coordinate. It's just going to be 0. Over here, if we moved straight to the left, then we're going to be at -1. And if we move straight down, then we've not moved in terms of x, so that would just be 0. Okay, let me do the same ones there for sine now, the quadrant angles, as we call them. So if we've moved straight to the right, and we're at 0 degrees, then we've not moved in terms of y. We've not moved in terms of sine, so that's going to be 0. If we move straight up, then we move up 1 unit, so the y-coordinate is going to be 0, so the y-coordinate is going to be 1. If we move straight left, then the y-coordinate is going to be 0, and if we move straight down, we would be at -1. Okay, so now we know the quadrant angles for cosine and sine if we have this much built of the unit circle. So for example, if I was to ask you what is cosine of pi over 2, you would tell me, oh, cosine is the x-coordinate is 0. Or what is sine of 180 degrees? You'd say, oh, it's the y-coordinate over here. It would just be 0. Okay, and now let's fill in these angles here, which are maybe the trickier ones to memorize, but they're also maybe the most important ones. They come back time and time again. So this is the way I think about it. Let's do sine first, or the y-coordinate. They are all over 2. So I'm just going to fill in all of them over 2. And then they increase as you go up the circle. If you're doing sine, it increases as you go up the circle from 1 to 2 to 3. But we also have to put square roots on each of the numerators. So it's the square root of 1, but the square root of 1 is just 1, so we don't really have that. It's the square root of 2, which is square root of 2, and then we have square root of 3. Okay, so if someone's to ask you what is sine of pi over 4, you'd be like, oh, sine of pi over 4, that's this point right here. It's the y-coordinate, square root 2 over 2, so you would be able to find that very easily if you had this memorized. Cosine is exactly the same. It's just instead of moving up the circle, it moves down the circle. It's just the opposite of sine. So what I mean by that is sine was, well, they're all going to be over 2, just like the sines were. But now, instead of starting with 1/2 down here, the 1/2 starts up here. So we have 1/2, and then we have square root 2 over 2, and square root 3 over 2. So just remember 1, 2, 3 is what I remember. They're all divided by 2, and remember 1, 2, 3. So we're moving up 1, 2, 3. Of course, with the square roots, or if we're going for cosine, 1, 2, 3 going down. Okay, so if you have that, you should be able to find the x and y coordinates for any of the common angles on the unit circle in any of the other quadrants. So for example, I guess first thing I should say, this is really what you should be writing out every day. As long as you can write that out every day, you are in good shape. It should not take you more than a few minutes. If you get stuck, look it up and just figure out the ones that you missed. But ideally, you should be able to fill that all in without any mistakes. Okay, so once you have that, you can basically find any of the equivalent angles in either quadrant 2, 3, or 4, and you can find the x and y coordinates no problem. So for example, maybe I was to draw, oops, didn't mean to zoom in there. Maybe I was to draw an angle in the second quadrant here, and I'll just write the radian value. Maybe this is 5 pi over 6. And I would know that since 5 pi over 6 is 1 pi over 6 above the negative x-axis, the reference angle is going to be pi over 6. So that means I'm going to have the same x and y coordinates as pi over 6, except for the signs could be switched. So this is what we're going to have. We're going to have the same x and y coordinates. It's still going to be square root 3 over 2, comma 1/2, except for the signs could be switched. Maybe they could be positive or negative rather than positive as they were in the first quadrant. And how do you know? Well, just think about where you are in terms of the xy coordinate system. If we are in quadrant 2, then that means that we are to the left of the y-axis. If you're to the left of the y-axis, then that means that your x coordinates are going to have to be negative. So that means we don't have positive square root 3 over 2, we have negative square root 3 over 2. What about the 1/2? Well, we are above the x-axis. The y coordinates are positive above the x-axis, so we do not need to change the 1/2. Or if someone asks you, I don't know, let's just create another one here. Maybe we've got, let me go over here. We got this angle, and it is, let's say it is 5 pi over 3 over here, right? Is that angle? So how do I know the x and y coordinates? Well, 5 pi over 3 is 1 pi over 3 below the positive x-axis, so the reference angle is going to be pi over 3. So that means I'm going to have the same x and y coordinates. I'm still going to be at 1/2 square root 3 over 2. The only change is the signs could be switched, and let me get that in the right color here. Square root 3 over 2. I'm getting little markings here. So will our signs be switched? Well, we have to think about where we are. We are below the x-axis. So if we're below the x-axis, then that means that our y-coordinate has to be negative, so we would actually have negative square root 3 over 2. What about the 1/2? Well, we are to the right of the y-axis where x would be positive, so we're in positive x territory. We do not need to change the 1/2. Okay, so make sure that you can do this. Do this every day, like I said, for 2 weeks. It's so important that you know your unit circle, and things are going to be so much easier for you if you have this memorized later in trigonometry and even in calculus. So I highly, highly, highly recommend that you memorize your unit circle.